All right, here we go. Question number 8 from our Precalculus homework number 2 in My Lab Math. We have another interactive figure problem where we're going to open up the window. We're going to click the Show H of T box. We're going to click the Time Play button in order to trace the path of the ball. And then we're going to look for the maximum height of the baseball. Notice we do have two parts in this problem. Opening up our interactive figure, clicking the Show H of T, and instead of click and play, I'm just going to drag that over to get it over with. We can see that we have the exact same figure that we had in the previous homework problem. The domain is from 0 to 4.5 again. This time we want to know when does the ball reach its maximum height, and that appears to be at time equals 2. Now, in order to verify that result algebraically, we're going to recopy our function here in our scratch work. We're going to identify the values of a, b, and c, and then we're going to recall that the maximum or minimum point on a parabola always occurs at the vertex. The formula for the vertex is h comma k. In our particular scenario, h, which is the x-coordinate, would be the time, and k, which is the y-coordinate, represents the height. So we're only interested in time at this point, the time that it takes to reach the maximum height. And so we need the formula for h, which is minus b over 2a, which would be minus 64 over 2 times negative 16. And if you do the calculation in the calculator, you're going to get a value of 2, which does verify what we interpreted from the graph. And so now all we need to do is come over to our window and verify that result. Now, part 2, they want the maximum height of the baseball. Do you understand the difference? The first question says, when does it reach its maximum height? Part 2 says, what is the maximum height? And we know the maximum height is the y-coordinate of the vertex, which would be k. If we go back to our graph, we can estimate that height to be about 100. It may be exactly 100, but the only way to know for sure if it is exactly 100 is to evaluate our height function when the time is 2. We need to calculate h of 2. So that's going to give us negative 16 times 2 squared plus 64 times 2 plus 36. And what a great opportunity to pull up the class whiz one more time. Putting in our calculation just the way it looks, we find that the height, well, it is exactly 100. So our graphical interpretation was spot on. And that's going to do it for this problem. So if you have any questions or comments about anything that I've covered, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.